Chapter 9, question 42. Graph and shade the solution for the inequality below. I'm going to quickly generate a small table of values here so that hopefully I can see what is going on with this particular function. And I'm going to pick some x values, and then I'm going to find the corresponding y values. So I'm going to let x equal, I haven't really thought about this, so I guess I'm just going to pick -4, -3, -2, -1, 0, 1, 2, and 3 perhaps. And then quickly calculate what this is, right? X squared minus 2x. Now this is, of course, an inequality, so what I'm doing here is I'm trying to establish the points that are on my boundary line. I can see, because this particular boundary line is less than or equal to, I know that it will be a solid boundary line, but I still need to know exactly where that boundary line is. So if, for example, x were to equal, say, -4, then I would have -4 squared, which would be a +16, and then that would be a +16 minus 2 times -4 minus 2 times a -4, which means actually it means +8, right? So all of a sudden, if x is -4, I believe this is going to produce a value of +24. That's quite large. If x is -3, I'm looking at -3 squared, which is a +9, and then -2 times -3, which means I'm going to be adding another 6. So I've gone from 24, and now I'm sitting at the number 15. I think I could just erase. No, I can't. If x is -2, I'm looking at -2, squaring that, and then we're going to have -2 times a -2. So I'm looking at +4, and then a plus another 4. So now I'm at the number 8. If x is equal to 1, -1 rather, -1 squared is a +1, and then I would have a -2 times a -1. Actually, that's what x is, -1. So I'm looking at a +3. At 0, I produce the value of 0. That's nice, right? X's are 0. That function equals 0. At 1, then I have the value 1 minus, actually 2, which would be -1. At 2, I would have 4 minus, that would be 2 squared is 4, and then minus 4, that would equal the number 0. And then when I plug in 3, when x is 3, that would be a 9. Then I'd have a 9 minus a 6. 9 minus 6 is 3. So when x is 3, I would get 3. So I have, quite a few values here, and I think I have an idea of what's going on. It appears that, this looks like this function is going to bottom out when x is 1. It produces a value of -1. And I see a certain amount of symmetry here. So I think I'm ready to go ahead and try and plot this function. So let me just slide this up a little bit. And I want to grab an xy axis. I'm just going to drag this straight down and then over. Okay. So let's go ahead and plot some of these points that are around the center. So when I have a +1, let me grab a red. When I have +1 for x, the function's at -1. Oops. -1. When I have a 2 in the function, I get a 0. And also when I have a 3 in the function, it looks like I'm producing 1, 2, 3. Okay. And when I plug 0 into the function, I get 0. When I plug -1 in the function, I get a value of +1, 2, 3 right there. And then I see, the symmetry that I can exploit, right? When I go to -2, I'm at 3, 4, 5, 6, 7, and 8. That's -8. And I'm pretty certain that if I plugged in 1, 2, 3, 4 into this function, I would get positive 8 out of it as well. So I'm going to go ahead and just use this. This is my boundary line, and this is a solid boundary line. Again, it's solid because the inequality is less than or equal to. So I'm just going to go ahead and plug this in, and I get something, you know, along these lines here for this curve we call the parabola. Now that that's graphed, right, I need to decide if I'm going to shade above or below it. And some of you are looking at it and say, Mr. Roberts, its y's are less than that curve, so we're going to be shading below that, and I agree. Also, though, you know, we're always considering test values. My favorite test value of all, 0, 0, is not going to work here because 0, 0 is actually on the curve. So I'm going to, go ahead and test. Come back. So I'm going to go ahead and test. I think I'll test this point. I'll test x is 1, y is 1. If I plug x is 1 and y is 1 into this inequality, right? X is 1 and y is 1. That would translate to this. I would be saying that 1 is less than or equal to, let me put a question mark there, 1 is less than or equal to 1 squared minus 2 times 1. In other words, I'm saying 1 is that less, I don't know why I moved that over. I'm saying is 1 less than or equal to 1 minus 2, which is negative 1? Well, no. 1 is not less than negative 1. And it's not equal to negative 1 either. So I definitely am not shading above this curve, right? But I knew that already. So my solution then would be all of these regions here, right? As long as I am below this particular curve, all of these xy points would satisfy the inequality. Y's are less than or equal to x squared minus 2x.